So how's everybody coming on that 4-inch? Is everybody done with it yet? Got your WPS done? I've got one so far.
I still need to do one.
I need to finish it.
Okay. Try to get them done by Friday.
Yeah.
All right. Sound okay?
And you want those handwritten or printed out and handed to you, not submitted online anywhere?
It doesn't matter how I get it.
Okay.
You send it electronic or you make me a hard copy.
Okay.
I prefer the hard copy.
Okay.
That way I can put marks on it. And I guess if I get it online, I can always print it out and make marks on it, but I like to make marks on it and give them back to you so you
Okay.
learn a little bit. But so that'll pretty much wrap up 1104 for us, and I decided to start today on D11. I don't know if you have access to one of these or not. This is a 680-page document, something like that, 600 and some pages. I doubt that we look at every single page, but we're definitely going to look at the different sections of it. And if you recall from 1104, in 1104 there were some definite sections in it. You know, you had the table of contents, and then you had table of figures, and you had the table of tables. There's a list of tables. And then it gets into the sort of the components of WPSs with essential variables was first. And then components of WPSs, and then PQRs, and WQRs, which you should know what those are now. And as we looked through there, it had a lot of the qualifications, and then it had inspection, and it had quality assurances. So it had sort of this basic structure. And when we look at a D11, which is a much bigger document, morning Josh, which is a much bigger document, this is the first page of the table of contents, and it's divided into these major sections, and each one of these sections is known as a clause, a C-L-A-U-S-E, a clause. So there's clause 2, which deals with design of welding, and clause 3 that deals with pre-qualifications. There's a little bit of a unique difference with D11 in that when we get to this clause 3, it deals with pre-qualification of welding procedures. There's a lot of pre-qualified procedures in D11, and a lot of different codes use them. For example, when you're looking at ASME, American Society of Mechanical Engineers, the Section 9 code, there's actually an appendix at the end of the code, and it's a much bigger document than D11. But there's an appendix at the end of ASME Section 9 called Appendix E, and Appendix E has this wonderful list of pre-qualified procedures. Now, why would you want to use a pre-qualified procedure if you could?
Makes your job simple.
Huh?
Makes it simple
Makes it simple and
and cost.
it's cheaper. You can purchase one of those pre-qualified procedures at the end of ASME in Appendix E, and they cost about $200. And I actually have one that I can show you because I've purchased a couple of them. But that's kind of one of the differences. In API, There are no pre-qualified procedures. You gotta qualify every procedure, even though it's the same thing every single time. Pretty much. But, there's really no pre-qualified procedure unless you use another company's procedure. And in the API code, there is no specific referencing to not being able to use another company's WPS. So if I'm working for XYZ company and they want me to weld according to this procedure and they don't have procedures of their own, and I go over to Josh and I say, hey Josh, do you have a procedure for welding this material this way? And he says, oh yeah, I've got one of those. And I'll say, great, can I use your procedure to do this? And he can say, yeah, here's a copy of it. Or he could say, well, yeah, but I'm gonna have to ask you to pay me $100 to do that. But there's nothing specifically in the API document that says that you can't do that. But in ASME and in D11, there are specific lines that say, no, you can't do that. Each company has to qualify their own procedure. So that's the one good thing, bad thing about API, depending on how you want to look at it. But it's pulled us out of a couple of holes here and there. But in the D11, morning, Alex.
Morning.
In the D11, where we have these different sections, and you can refer to the table of contents if you have a specific question about a design of a skewed T or Z-loss or something like that. You can come into clause 2, and clause 2 is the design of welded connections. And so you can go down through here and you can find out the particular question that you might want to answer. And then if you're in a manufacturing situation where you're an engineer, a welding engineer, and you're looking at a new piece that they're going to make, or a new weldment that they're going to make, and they give you the job of taking a look at this new fabrication that you're going to do, and there are certain weldments that have to be dealt with, and you're going to look at it, and of course the first thing you're going to ask is what code are we going to do this under. And typically if it's a structural thing, you're going to use D11. And D1 has 9 separate categories. I just happened to purchase for one of my other senior projects. This is the D12, which is the code specific to aluminum. Okay, and there's specific things pertinent to aluminum in this one. 1.3 deals with one of the limitations of D11, which is thickness. D11 only goes down to 1/8. It goes unlimited, but it goes down to 1/8. If you're dealing with something that is less than 1/8 inch, if you're dealing with 14 gauge or 16 gauge, the D11 code is not going to cover it. So you have to purchase a separate supplement to it, which is, in this case, D13. If you're building bridges, and we've had a sort of a flurry in this country in the last 10 years of all these specialty bridge making, you know, like for parks, they make these beautiful pre-cambered bridges that go across a brook or a stream or something like that. Those guys have to make those bridges according to AWS D15. So there's all these different specifications for the D1 code that have subunits to it. D11 pretty much covers everything from 1/8 inch thick above to unlimited to a lot of different kinds of steels. And one of the other things about it is it has clause 3 deals with pre-qualification of WPSs. but then also within that section, there is a whole list of, I'm looking for it here, well, we'll get to it, we'll see it, but in clause 3, there's several pages of pre-qualified joints that you can just pick up and you can look at whatever it is you're working at the company where you're working as an engineer. Oh, we've got this joint, we've got this joint. Well, there's pre-qualified joints in the D11 that we could use. And we'll take a look at those, okay? And then, of course, qualification is the next thing listed. And just like in the API where we had that section on qualification, 2 things have to be qualified. And you should know this by now. Procedure and the welder, okay? So under qualification, which is clause 4, you have these WPS qualifications, the essential variables. You'll notice a lot of the same language. It's just a lot more wordy, and there's a lot more pages involved. And I've had to work under D11 a lot, but when I go to Miami and go to these meetings and these seminars and meet with these people, and they want you to come down and look at their changes to their code. You know, it's almost like dirt types. You know, there's a few kind of dirt, sandy loam, clay, and mixtures of the two. To me, the D1 code is like that. It's basic plain Jane welding. And I think they have a stigma, the D1 code boys down in Miami. They have this stigma about the fact that it's such a simple code and it's such a simple way of welding things that they've made it extremely complex because they have this inferiority complex that what we do is so simple, you know, and the ASME people and the other people, they do things that are much more intrinsically different, and there are all these different kinds of materials that they use. Well, D11 we're mostly welding with A36 steel or A500 or, you know, maybe some of the other duplex kinds of steels. Oh, no. We have to be a lot more scientific than that. Well, they have taken a document that is about this big and was a lot like the API code to where it is now. Let's just see.
648.
Well, it's at least 577 pages long. Okay, so it gets more complex as you go through it. But you'll see as we go through this and look at the table of contents, there is a lot of the very same things that you have seen in API. Clause 4 deals with qualification of both procedures and welders. And then 5 deals specifically with fabrication, and it has 2 different sections to it, 2 parts to it. And then inspection, which is something that you'll be doing a lot of. There's a clause for inspection, and they've actually made a couple of new ones. Stud welding, we'll take a look at stud welding specifically, because there's some unique things about stud welding that you need to look at. And for the construction industry, studs are used a lot. They weld them onto steel structures, and then they cast concrete in this area. What do the studs do?
Keep everything.
Hold the concrete to the steel? No, that's not the main reason for studs, and this is something you'll learn today. The placement and the number of those studs is to create a shear plane. So like this wall here, this is a supporting wall, but if you could imagine this wall as one component of the structure of this room or this building, it creates a shear plane that holds that wall in place, the roof, and is connected to the floor, and it keeps it from shifting. It creates a shear plane. Those studs in the concrete plane holds the concrete together so that it creates a shear plane, and that's the basic reason for studs. So we'll take a look at studs. And then this is the newest section to this, where they've added a tubular section.
Does the studs, is it any different for threaded studs?
Is it any different than it is studs?
No, for threaded studs?
Oh,
Is that the same section?
it's a little
or
different. It's a little different, but some of those are in tension, but most of them are like shear. Most of them are rated for shear.
Gotcha.
But that's a good question, because some threaded studs are used to hold in tension, in tensile. So yeah, but most of the studs that we're looking at here deal with those Nelson studs, where you shoot them down onto steel and then they pour concrete over them. But they use them in walls, and they use them in different places to, attach a stud so that you can hang something else on it, and that's usually in tension. That's a good point. We'll take a look at that. This is the new one, which is tubular structure. I say new, everything seems to be new to me, but it's probably 10 or 15 years old now, because they didn't like the fact that, tube shapes like square tubing, rectangular tubing, even round shapes, they don't call it pipe, they call it round. We jokingly call it O-beam. You maybe have heard of that. We jokingly call it O-beam, because they don't like to use the word pipe, because they're not really a pipe code per se. So these guys are a piece of work when you ever get to meet them. So there is a new section about tubular sections, which is a little bit more involved. They've fleshed this out to have quite a bit of more information to confuse and frustrate the contractor. Here are the annexes, and you'll notice there are lots of different annexes. One of the more important annexes here is the having trouble finding it. Sample welding form, right there. It's Annex M. This is an annex that has a bunch of sample welding forms, and you'll be using this for this part of the class. And they also have there's a filler metal classification guide, and there's also one that we'll be looking at this morning if I get that far. So a list of tables. There's lots of tables, lots of very confusing tables in D11. We'll try to sort through that with you. A lot of them. And then we get a list of figures. There's also figures which are very helpful. I don't know about you, but I'm sort of a picture guy. I understand a lot more from looking at a picture than 6 pages of text. So at least they include some figures for us to help us along the way. So we're going to look at, first of all, this is clause 1. It's not very long. It's only a couple pages long. But the scope of this code book. So it's interesting, some of the language that is used. The code contains the requirements for fabricating and erecting welded steel structures when this code is stipulated in contract documents. Conformance with all provisions of the code shall be required, except those provisions that the engineer or contract document specifically modifies or exempts. So what does that tell you? What does that say to you, Marcos? Anybody?
If that's like your go-to document, if you have any questions on the project, unless it's obviously specified otherwise.
Yeah, if it's specified in the contract documents, you can use it, or use it as a guideline. Correct statement? No, not at all. Why? What's the operative word there? Shall. And if we look a little further under definitions, let's just go to definitions. Down here, 136. Code terms shall, should, and may shall, should, and may have the following significance. Shall. Code provisions that use shall are mandatory unless specifically modified by the engineer. Now, that could be you. That could be you. Okay. But it has the weight of law. I hope that you never end up in court. I really hope that you never end up in court. And I never hope that you're the guy on the stand that has to do the testifying to this stuff too, but it can be pretty hairy. You'll find out things like, I have one of my examples, you know, you are the inspector on the job and you are in spotted horse and there's no cell service, and it comes to the end of the day and the engineer wants this section completed today. And about 3 o'clock in the afternoon, the sun goes behind the mountains and it's December 20th in north central Wyoming. What happens when the sun goes behind the mountains to the material you're working on December 20th?
It gets cold.
It gets colder. And what happens to it? It shrinks. Exactly. And you say, okay, that's it, let's go home. And the welder's like, oh no, come on Josh, we can do it. Just give us 10 more minutes and we can get this done. No, you're not gonna make it. Just wrap up your stuff and let's go. No, come on, give us 10 more minutes. No, let's go. And you go back to your truck and you hear bang! And they've tried to pull two things together and it snapped. And it's struck somebody in the hip and shattered their hip and their femur. Now you have to call Life Flight to your GPS coordinates, fly this guy back to another town to get emergency medical treatment. 3 months later, you're in court and you're on the stand. And the attorney, the prosecuting attorney, I mean, you've been examined and you've testified that, hey, I told him to stop. I told him 3 times to stop. And I said, let's wrap up, let's go home. And I went back to get in my truck to go home, and they tried it one more time, and the steel snapped because it got so cold, and this piece of steel went over and hit this guy, broke his femur, and shattered his hip and broke his femur. And I called for emergency, and I told him to stop. And the attorney says, but did you make him stop?
Such bullshit.
And they rule in favor of the guy that did exactly what he was told not to do, and you and your company have to pay $2.5 million. I'm telling you, this is real life stuff, I'm telling you. So, these words like should, shall, may, I mean, you need to enforce these things as they are defined. So we'll have fun with that one later. Okay, so that first clause right there. This code contains the requirements for fabrication and erecting welded steel structures. When this code is stipulated in contract documents, conformance with all provisions of the code, everybody say it, shall be required, except when the engineer changes it. The engineer calls and says, hey, you know, I don't think you really need to do that, so go ahead and do this or that. Okay, see you, bye, that's what we'll do. And then you do that, and then something goes haywire, and you're looking through your papers for something for that. But he told me that we could do that. I never said a thing about that. You cover your ass with documents on paper. It's commonly, jokingly said, but it's really not a joke. When the weight of the paper equals the weight of the project, it's close to being done. Okay, so I want you to see that. Limitations. Code was specifically developed for welded steel structures that utilize carbon or low alloy steels that are 1/8 inch or thicker, with a minimum specific yield strength of 100 KSI or less. There's your limitation. Pretty broad, right? That's 99.95% of all steels that you're gonna deal with out in the structural world, but there are limitations. So feel free to take pictures of this, or if you've got, you know, capabilities of getting this online. This happens to be a version that I bought. Paid $389 for this thing, and I can't even highlight it because they're so weird. So feel free to take pictures of it and make your own highlights if you want to. These things that I'm pointing out, or if you have a photographic memory, then remember these things. So this coat is limited to 1/8 inch or thicker, and steels of 100,000 KSI or less. So if you're dealing with a duplex steel that has 120,000 KSI, does this code apply?
Sorry, what?
No.
If you're working on a steel that has 120,000 KSI duplex steel, does this code apply? No, you can't use this code. It's pretty much for vanilla steel. Well, I like to call it vanilla. Pretty much all the steels, A36, A500, A517, all pretty, and we're gonna look at a chart. There's a whole big chart of this in here, okay? And it refers down here. The Structural Welding Committee. Oh, that's a bunch of, those guys or something. Encourages the engineer to consider the applicability. I was pulled out into the hall one day when I was down there, and I was arguing with them about something that we'll be talking about here, complete joint penetration. And I was pulled out into the hall by one of the 24-year-old welding wonders, and told, stop arguing with that guy. I'm sorry. Isn't this a forum where we're trying to discuss problems and make it better? But you don't understand who you're arguing with. You know, that's Dr. Richard blah, blah, blah. And we don't argue with him. Well, why did you invite me here to sit here and have this, you know? No, I'm not gonna do that. Please, I'm just begging you, please don't argue with him because he'll walk out. Where do you get these guys? You know?
Fine, I'll take my ball and go home.
Well,
Asshole.
I mean, they were putting me up in a really nice hotel and taking me out to dinner every night, but.
No, I mean the other guy.
Oh, him, yeah.
He's that douche that,
You see that line up there says Structural Welding Committee? That is one guy of about 50. And I've got letters in here that I can show you that I can back up what I'm talking about here. These guys are freaking idiots, but they write the code. So, Structural Welding Committee encourages the engineer to consider the applicability of other D1 codes for application including aluminum. And here's what I was showing you, D1-2, sheet metal D3, reinforcing steel D1, stainless steel D6, strengthening and repair of existing structures D7, seismic supplement 1.8, and titanium 1.9, and then the AASHTO AWS D15 bridge welding code specifically designed for welding highway bridge components and is recommended for these applications. So there's a breakdown of the D1 code into these smaller subunits. I want you to know that. Titanium's a separate one, aluminum's a separate one. Reinforcing bar, rebar, is another one. Why? Because now we have welded rebar. We used to not have welded rebar. After 1984, when the Mexico City earthquake occurred, and 80% of Mexico City fell to the pavement, and it was because they were welding unweldable rebar. Why can't you weld rebar?
brittle.
Brittle, too much carbon, way too much carbon. But now they make a weldable version. How do you tell the difference? How do you tell the size of rebar?
I don't remember.
Really simple. Every number, it starts at 3. Number 3 rebar is 3/8 thick. Number 4 is 4/8 thick. Number 6 is 6/8 thick. They're all numbers of how many eighths thick it is. But instead of it being just like 8, it'll say 8, If it has a W in front of it, W8, that's weldable 8. And they keep the carbon content down low enough that you can actually weld on it. It's actually fairly low carbon steel. But you put that in concrete to keep the concrete from, because concrete has very low ductility. So they put that in to keep the concrete rigid so that it doesn't move, so it won't crack. But there is a code for rebar, for welding rebar. Okay. Responsibilities, I think I had something I needed to mention here. Yeah, the engineer may add to, delete from, or otherwise modify the requirements of this code to meet the particular requirements of a specific structure. All requirements that modify this code shall be incorporated into contract documents. Now what does that tell you? We just referred to that a second ago. Paper. You've got to have a document that says we're modifying this. If you don't have that, your ass is going to get hung. I guarantee it. The engineer shall determine the suitability of all joint details to be used in a welded assembly. The engineer shall specify in contract documents as necessary and as applicable the following: code requirements that are applicable only when specified by the engineer. Additional NDT. What's NDT? Okay. Verification inspection, which is different than regular inspection. It's a separate hold and stop short inspection.
Isn't it an inspection to verify that it was inspected? Is that not the case?
I think that's the case in a lot of times, but it's like if you have 3 steps, and between step 2 and step 3, the inspector has to verify that these welds were the correct size and all that, so that before you get covered up. Exactly. Studs. You might get called in to do a stud inspection, where you take a piece of 1 1/4 inch heavy wall pipe about 5-6 feet long, and you stick that over the stud. And basically, if you pull it to your body, you've pulled it 10 degrees, depending on how tall you are. And if it breaks, then you have to do a certain percentage in that field. But as you're going through, you pick out certain ones and you bend them. And if you have no bends, then okay, you can pour the concrete now. Verification inspection that the welding was done correctly. Okay. Weld acceptance criteria other than specified in clause 6, which is inspection. CVN test. What is CVN testing?
No idea.
Charpy V-notch. When do we do Charpy V-notch? CVN testing. When the material has to have a impact toughness at a lower temperature. I'm working with a company now that's going to be putting 8-foot diameter tubes underneath the Salt Lake Temple for seismic. And there's a weld right in the middle of these 8-foot diameter tubes that are going to be jackbored underneath this thing. And for some reason, they have to have a CVN test to them. What is the temperature at 35 feet below grade?
70 year round.
Yeah, it's
Well,
80, it's 68 to 70 degrees year round. But we have to have CVN testing. Well, it's probably the cover your butt thing. Because if something happens, this is a pretty important structure in Salt Lake City. And if you have an earthquake, and those pipes, they don't want to call them pipes. They're round beams. They're round tubular shapes. If one of the weld fails, then somebody's going to come back and why did it fail? Because we didn't do Charpy V-notch. Well, then you're in trouble, and your insurance company's going to pull you up. So Charpy V-notch tough. For weld metal, base metal, or HAZ when required. So there's all of these, what's OEM?
Original.
Equipment manufacturer. For original equipment manufacturers, the responsibility of the parties involved. So if you're building something that's going to be a piece of equipment that goes out, if there are OEM requirements, applications, this widget will, under these pressures, under these conditions, will last for, we warranty this for 5 years. So an engineer can go outside of the code for those sort of things. All right, contractor shall be responsible for WPSs, qualification of welding personnel, the contractor's inspection, performing work in accordance with the requirements of the code. Inspector's responsibility, and this we had that nice little discussion first week of school about who gets to accept and who gets to reject. And is not accepting the same as rejecting? Okay, so contractor inspection, third party is what it's talking about here, third party contract inspection. I do that all the time. Shall be supplied by the contractor and shall be performed as necessary to ensure the material. I had to test a welder last week. They wanted a third party inspector, so I had to go down and watch him do a ASME weld. He's going up into Oregon somewhere, Lakeview, to weld. They're doing something there. It was kind of a cool project, but I had to perform the work as a third-party contractor. So verification inspection. Notice there's two different declensions here. The engineer shall determine if verification inspection shall be performed. So you might be either or of these people. You might be the engineer. Most typically, these engineers we're talking about here are stamping engineers that have a mechanical stamp or a structural stamp or something like that. And I have lobbied for years. I've lobbied 30 years that welding engineers need to have their own stamp. And I have not been successful because of the D11 committee.
Wait, what?
To become a PE, none of these drawings have a stamp on them. But to be a PE, a principal engineer,
Yeah.
that's the one that has the little embosser that embosses drawings, or he is the principal engineer. He's the engineer of record. Most of those guys are structural engineers, mechanical engineers, civil engineers. They have a stamp. I have lobbied for years because of the inadequacies of these stamping engineers who don't know their backside from first base when it comes to welding. They take a 2-week portion of their class somewhere where they learn welding symbols and they learn all about welding, you know,
My
and
brother-in-law.
they're experts in welding now because they've, you know, but you get these drawings and they've got a welding symbol with no data on them. Or they got a multiple step weldment here that has one welding with a flag. You know, they really don't know that much about the welding industry, and so I have lobbied for years that the prints, the plans, the designs, everything should go through a welding engineer prior to a principal engineer stamping and approving them, because we get stuff from structural engineers all the time. I think I've told you stories about, you put that in just exactly like I drew it. But you got to see right here, it's like, no, you put it in exactly like I drew it. I don't want to hear from you again. I'll be back next week. You want me to build it like this? Yes, just like I drew it. Okay. So we start off over here. We come up off of the pump, and we put the pipe at grade exactly like he's drawn it. You know, you're trying to point out a 1/2 inch per foot of grade is going to have this pipe going through the roof by the time it's on that side of the room. You try to tell them that, and you get demanded in front of other people. You build it just exactly like I drew it. I don't want to hear from you again. That's a quote from an engineer in Tyler, Texas, on a project I was doing at the Central Valley Water Project in Salt Lake. I said, okay, all right. So we start building. I call in the concrete cutting people, because I need a hole cut in the ceiling now, 1 foot thick concrete, reinforced concrete. I have to have a hole cut now so I can run this pipe up through the ceiling. And he came back a week later, what the hell? What are you doing? What are you doing? I said, I'm drawing it just like you drew it. You took, well, I didn't mean to do that. It's like, all these people here heard you. You told me to build it just like you drew it, so we built it just like you drew it. So I've said for years, welding engineers should have the capability of having veto power on drawings and analysis input on drawings, but to date, they refuse to let welding engineers have any seat at the table. So,
Well, you see the same thing here at Weaver.
it's,
The mechanical engineering students, they're quite, I mean, there are some good guys, but most of the time they're just like, oh, you only took calculus 1. You haven't taken linear algebra. So,
yeah, I've heard that all before, many times before. But that's what you run into, especially with this code. So just be advised of the animals in the forest that I'm telling you about, so that you know not to step on a snake unless you can crush his head.
exactly.
Okay.
Just aim judiciously.
Yeah. So what happens, sometimes you gain the respect that you should get. I mean, mutual respect is so hard to get because of the ego trip so many people are on, but it's hard to get. There's not too many more things here. Of course, welding symbols have to be followed according to the AWS standard, not somebody else's standard. There's some other regulatory things here. Standard units of measurement. Standard makes use of both U.S. Customary and international. The international metric will always be in parentheses in this book. And then that's pretty much it for clause 1, and we can stop there for today. But these things that I'm pointing out, make sure that you make note of them somehow, because we're back to the weekly quiz thing. So come Friday, I will have, a 4 or 5 question quiz for you on the stuff that we're covering. So if you don't make it, if for some reason you don't make it, I'm recording all of these so that you can catch up on them, okay? Once again, you can pretty much find an old copy. There's going to be differences. This is the 2015 edition. There are newer editions. They typically upgrade those every other odd year. So there's not going to be a new one this year, but there'll be a new one next year. There's one in 2019, 2017. But they're very expensive. This particular one was about $200. This one right here. Okay. So
See, but that's a lot more useful than a lot of textbooks that I have.
it really is. It really is. And I wished I could just print copies of this and give it to you, but I'd probably end up in the AWS jail. Where they would
It's not a
probably
real place.
They would probably punish me by sitting me in a room and making me watch endless lectures by these people from this D11 committee, and they'd leave a knife on the table so I could slit my wrist at some point. Okay, that's clause 1. See you on Wednesday. Try to get your coupon spent if you haven't got that done. Alex actually got everything done. Here is and I put your score in for this. So you're pretty well caught up. Check your grades, make sure you have everything in. If you don't, then let me know.
Thank you.
You bet.
And
Josh, could you hit the
Yeah.
video thing for me? Kill it. Yes.